Good afternoon. Okay, I will explain about step function to express the shear force. Okay, the first is, what is the step function? Step function is defined as ut, or simply, because we don't talk about the time, but we talk about the location. So u x minus a. This will equal to 1 if x larger than a. And then it will equal to 0 if x smaller or equal to a. For example, we have this function. So this is the function of x, and then this is the x-axis. And then suppose we have the function that it has the value of 1 after x equal to a. So this function is expressed in the step function in this expression. Okay, then now suppose we have a simply supported beam. And then the beam is subjected to external loads. For example, in this location, that is 3 kilonewton. And then the distance of the working external load have the position 2 meters from the left and then 1 meter to the right. Then how is the reaction, do you think? Okay, this is the simple number. This is 2 plus 1 is 3. And then this is the load. The load is 3 also. So it means this load will be divided into 3 portions. And then 2 portions will be given in one reaction, and then another 1 portion will be given to the other reaction. So since this reaction, this support is nearer to the load, so 2 portions will be given here. So this is the reaction here. So for example, this is P, and then this is Py. So it will have the value 2 kilonewton. And then the other side, pin support. In general, it will give in 2-dimensional 2 reaction, horizontal direction and then vertical direction. In horizontal direction, there is no external load in horizontal direction. So we have the value 0. So this is A. And then in the vertical direction, we will have 1 portion of the external load. So Ay equal to 1 kilonewton. And then what do you think about the transverse force, internal transverse force working in this beam? So if we cut the beam in this location, so at the position between A and C, so we will have the free body diagram here. So this is Ay, that is equal to 1. And then at this location, there will be shear force, internal shear force. So this is P equal to 1 also, if we apply the equilibrium of forces in y direction. So this is 1 kilonewton also. And then if we want to draw this internal shear force, we must remember about the sign convention. Shear force is positive if the shear force will rotate the element clockwise. So it means this is positive. And then now, suppose we cut at the other part. So suppose now we cut at the location between C and P. So we can draw the free body diagram from A until the cutting position. And then similar. At A, we will have 1 kilonewton, and then at C we will have 3 kilonewton external loads downward. And then at the section of the cutting, we will have external force, external shear force. If we place this is positive, this is P as positive. So taking the equilibrium of forces in vertical direction, so it will become, this is 1 kilonewton, downward 3 kilonewton, so this part should be upward 2 kilonewton. So it means actually the value of phi is negative. So this is becoming 2 kilonewton. And then this external shear force will try to rotate this element counterclockwise. So it means the sign is negative. So that is between A until C. If we cut the beam, so we will have the shear force 1 kilonewton positive. And then if we cut at the beam between C and B, we will have internal shear force 2 kilonewton negative. So it means if we draw the shear force diagram, so this is 2 meters and 1 meters. So in that direction, X. And then Vx in this case is in Newton, while X is in meter. Then we have the first is 2 meters. And then here from A, if A is mid 0, so we will have 3 meters. Then between A until C, we have 1 kilonewton. So it means we have here 1 kilonewton. And then between C until P, we have minus 2 kilonewton. So it means we will have minus 2 kilonewton. So here we will have this force. So this is the shear force diagram for the beam. So the internal shear force diagram along the beam. If we include the sign, this is positive, and then this is negative. Okay? Okay. Now we are trying to express the shear force diagram in step function step function multiplied with the needed constant or the needed function. Okay, if we see here, so it is started from Vx started from 0, and then it is going upward, starting from 0 with the unit 1. So, and then at location C, there will be another force that will push this location, this value until -2. So it means this value from here until here is 3, but in the negative sign. Okay, and then here there is another force that will return back the internal shear force to 0. So that is +2. So it means this is +1, -3, and then +2. So it means if we express this function in the combination with a step function, so we will have actually, so Vx that will equal to, this is +1, and then this step function is starting from 0. So it means actually it must be multiplied with Ux minus 0. And then at C, there is another step function to -3. So it means we have -3, and then multiplied with the step function that is started from 2. And then the last at position of P, there is another step function that return the shear force diagram to 0. So it means that we will have +2, and then return back to 0 when x equal to 3. Okay, so this is the expression of the function of shear force using the step function expression. So it means now we can, since this is starting from 0, so we can remove this part. So it means every value after 0, the value here is still 1. So it means here we will have 1, and then here maintain. So Ux minus 2, and then the last is 2, and then multiplied Ux minus 3. That is the step function expression for internal shear force diagram. Is it right? Okay, let's see. If we see x is between A and C. So suppose now we see x between A until C, or x is between 0 until 2. So we will have expression Vx, of course, equal to 1, and then -3. Now since this value is smaller than 2, So using this definition, OX minus A, if X less than A, so it will become 0. So it means this function become 0. And then now 2, and then this is ux minus 3. Ux minus 3 will have the value 1 if x larger than 3. But here we see x is only smaller than 2. So it means this value equal to 0 also. So it means in this case, the value is really 1 minus 0 plus 0. So it means 1. Okay, here we have 1 here. And then now, if we see x is between C until P, or x is between 2 until 3, so we will have this function becoming 3x that is equal to positive 1 and then minus 3. Now see here, this step function will have value 1 if x larger than 2, and then the selection x is larger than 2. So it means this value becoming 1, such as here. And then we go to the next step. Now we have ux minus 3. This is the step function that will have a value 1 if x larger than 3, but will have 0 if x smaller than 3. And then this selection, x is smaller than 3. So it means this value, step function of this part for x smaller than 3 is 0. So it means in this case, we will have positive 1, and then this is negative 3, and then this is positive 0. So we will have negative 2. This value also, this is negative 2. So, okay, so it means this function is representing this shear force diagram. Agree? Okay, so we will see the application of step function to the next stage, that is expressing the moment force, internal moment force diagram using the step function. Okay, and then at the last, don't forget the unit. Oh, this is kilonewton, and then this is the final. This is kilonewton. This is kilonewton. Okay.